Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about rational and irrational numbers. So numbers that can be represented as a fraction a over b, where a and b are integers and b is not equal to 0, are called rational numbers. Numbers that cannot be represented in this form are called irrational numbers. So irrational numbers have no pattern. They don't end. They just keep going and going and going. You don't know really what to predict with them, so that's kind of why I made them different colors and different sizes. Radicals that are not perfect squares are examples of such numbers. So like the square root of 2. That's not a perfect square. It's irrational. All right, so we're going to look at some of these values, and we're going to decide if it's rational or irrational, and then we're going to give a reason why. And if you do this on your own, your reason why might not be the exact same as mine, and that's probably okay. So the value pi. So this is probably one of the most famous irrational numbers. So it is irrational, and it does not end. So pi goes on forever, indefinitely, and it does not have any pattern. Okay. 0. 0 is an integer, and all integers are rational, so it is a rational number. Negative 38, that is also an integer. Integers include negative and positive whole numbers, including 0. And the square root of 2, so square root of 2 is irrational. It's not a perfect square. If you kind of plugged it into your calculator, it'll show you the first couple of digits, whatever your calculator can hold, and you'll see that there's no real pattern, and then it just kind of keeps on going. 4.16, and then there's a line above the 16. So what that means is it's really 4.161616. If the line was just over the 6, it'd be 4.16, and then the 6 would be repeating. But because it's over both, the 1616 is repeated. So because it has a repeat, you know the pattern. It is rational. We know what to expect from it. So repeating decimals have a pattern. 55 over 2, well, that is written as a ratio. And if it's written as a fraction, a ratio, then it is rational. All right, this next one, 2.184297389, and then ... telling me it's going to keep going. Okay, but so far it's been going, but it didn't have any pattern. It wasn't like it was 8, 8, 8, 8, ... to make you think that it was going to be 8s continuing. So this would be a non-repeating, non-terminating decimal, so that would be irrational. And then the square root of 49. Well, the square root of 49 is actually 7. It's a perfect square, and that's an integer, so that would be rational. All right, integers, like I said before, integers are negative and positive whole numbers, including 0, and integers are closed under addition, subtraction, and multiplication, which means if you take two integers and you add, subtract, or multiply, you will always get an integer. Okay, so now we're going to talk about if it's always rational. If you take a rational number and an irrational number, will it always be rational? Will it sometimes be rational, sometimes be irrational, or will it always be irrational? So these are some of the different situations that you might have. The sum or difference, so if you're adding or subtracting two rational numbers, it's always going to be rational. So if I take the square root of 81 plus 4.2, well, square root of 81 is a rational number because it's a perfect square, so that would give me 9 plus 4.2, which would give me 13.2, and that is rational because it ends. It's a decimal, but it doesn't keep going. 2.75 minus 1.22222, and that 2 keeps repeating. You would get 1.57 or 1.527, and in your calculator it would be 777, and the last digit in your calculator would be an 8, because your calculator is going to automatically round that last number up for you. But really, when you see that 7 repeating multiple times, you know that that's what's going to be the repeat. If you had a repeating number, it's going to always, like when you add it with something else, it's still going to have a repeating number. Okay, the sum of two irrational numbers might be rational and it might be irrational. So if I have the irrational number, square root of 2 plus the square root of 2, they're both irrational, and I'm adding them, that's going to give me 2 square roots of 2, and that is still irrational. If I take these expressions and add them, if I have 3 plus the square root of 5, and I add it to negative square root of 5, that would leave me with just 3. Both those expressions were irrational to begin with, but it leaves me with a rational answer. So sometimes it'll be rational, sometimes it'll be irrational. If you have one rational number and one irrational number, so the sum or difference of any rational and any irrational number is always irrational. So 6 plus pi. 6 is rational, pi is irrational. That's going to give me just 6 plus pi. There's nothing else I could do with it. The pi is irrational, and so that expression is irrational. The square root of 5 is irrational. Minus 8, which is rational, would just leave me with the square root of 5 minus 8. And again, it's still irrational. The product of any two rational numbers is rational. If I multiply a rational number times a rational number, I'm going to get a rational number. So here are some examples. The product of two irrational numbers might be rational and it might be irrational. So if I take the square root of 2 times the square root of 8, both are irrational, that gives me the square root of 16. And the square root of 16 is 4, so now my answer is rational. If I take pi and I multiply it times pi, they're both irrational. That gives me 2 pi, which is still irrational. So sometimes it'll be rational, sometimes it'll be irrational when you're dealing with two irrational numbers. If you have a mix, one's rational, one's irrational, 8 times pi, and you're multiplying, you're always going to get an irrational number. So it's going to give you 8 pi, which is irrational. Square root of 81 times the square root of 2. Square root of 81 is 9, so that is a rational number. Square root of 2 is irrational, and when I multiply, I get an irrational number, a non-repeating, non-terminating decimal. All right, classify the result of the following expression as rational or irrational. So the square root of 9 plus pi. Well, the square root of 9, that's a perfect square, so that would give me 3. So that's a rational number, and then I have pi, that's an irrational number. So I have a mix, so I really need to look at it. So I have 3 plus pi, because I took the square root of 9, I got 3. And that I can't really do anything to simplify that any further. And because it has an irrational number in it, it is irrational. All right, I have 16 to the 1/2 power. Well, anything to the 1/2 power is really like the square root. So I have the square root of 16 minus 2.5. Well, square root of 16 is 4, so that's a rational number, minus another rational number, 2.5, so that's going to give me a rational number. So 1.5 is rational. The next one, I have square root of 3 times 2 square roots of 5. So I have an irrational number times an irrational number, so I know it's going to be irrational. All right, that's it.